Welcome back to Calc Lectures. This week we are going to focus on a technique of integration called u-substitution. This is the technique that you explored back in week one. I'm going to give you more examples and we're going to formalize the process, and then we'll see a variety of different applications for this. So I have a typical problem that you might be faced with. We're asked to find the antiderivative for 3 over 4x minus 5. And as we can see, this doesn't fit any of the actual formulas that we have from our table of integrals. So we're going to have to kind of make things up as it works. Now, basically, the function this looks most like is 1 over x. But it's not 1 over x. It's something different. To make this look like 1 over x, if we thought of this denominator here as a variable, then we could make it look and have the right shape. So we're just going to do that. We're going to let u be the new variable 4x minus 5. So this changes the form of the variable. And when we rewrite this, it now becomes something that looks like 3 over u. But the price we pay is we also have to change what dx looks like. To solve that, we're going to take the derivative, du with respect to x, and we take the derivative here, and it becomes 4, which lets us solve for du by saying du is 4 dx. This means that in our original expression, we can replace this by this, right? So these are the same, which means the 4x minus 5 becomes u, and the dx right here is the dx right here. So dx is going to be du over 4. And now that we've identified the pieces, we can rewrite our integral as the integral of 3 over u times, instead of dx, du over 4. And now we can pull out the coefficients, the 3 and the 4, out front. So we have 3/4 of the integral du over u. Now, the antiderivative of 1 over x is the natural log of x in absolute value. And so we get exactly that here. This becomes 3/4 of the natural log of the absolute value of u, plus everyone's favorite constant c. And now we have to back substitute because our problem wasn't to find the antiderivative of u, it was finding the antiderivative of 3 over 4x minus 5. And so we're going to put our u back in. So instead of u, we're going to have 4x minus 5 right here. So our last step is going to be 3/4 of the natural log of the absolute value of 4x minus 5 plus our constant. So the integral of 3 over 4x minus 5 dx is equal to 3/4 of the natural log of the absolute value of 4x minus 5 plus c. This technique can be done in a variety of ways. Let me show you a couple other ones. They get fancy, they get complicated, but it's always the same game we play. The game is, how do I find my derivative? If I can spot the derivative with the function, then I know what has to be my u and what has to be my du. So let me give you one that's a little bit trickier to spot. Let's say we want to do the integral of 1 over x natural log of x dx. Now remember, the derivative of the natural log of x is 1 over x. That means the 1 over x plays the role of derivative, natural log of x is going to be our u, right? If u is natural log of x, then du is 1 over x. So this is going to be the exact setup we want. So we let u be the natural log of x. Then derivative is 1 over x dx, which means that 1 over x dx will be replaced exactly by du. This piece is du. And so this means that the whole expression becomes the integral of 1 over u du. And once again, we have to find the antiderivative of 1 over u. Well, we've already said that's the natural log of the absolute value of u. So this becomes the natural log of u plus your constant. But now we have to back substitute because u is the natural log of x. So this becomes the natural log of absolute value, the natural log of x. Let's see. So it looks a little bit silly, it looks weird, but this is correct mathematics. The antiderivative, it's not that difficult, but it is tricky to solve these. So I'm going to give in the next videos a few more general techniques. We're going to look at how this works with some trig functions, some inverse trig functions, some special cases. And that should be pretty much the material for this week. Remember, the big thing happening this week is you are taking your first exam. So good luck with that, and I'll see you later.